Welcome to Tech Teach.
Types of parameters are there that basically define the quality of the line encoding. So characteristics, we will just see the parameters defining characteristics of line coding. So different parameters are there that will be basically defining the different characteristics of line coding. So whatever the line coding is done, what is the efficiency of how it is performing. So there are different parameters that will be defined to identify that. So these different parameters are considered as like one is called the bandwidth itself, bandwidth. Second one is called baseline wandering. Third, complex is the system to implement, so complexity. Next one is called DC components. So I will just explain like what this is basically, how we will be defining whether it is complexity or how it will be defined basically. Okay, so one is called like self synchronization. Next is called like the built-in error detection, built-in error detection. And the seventh, we can name it like immunity to noise and interference. These are the 7 different parameters that will be defining whether a particular line encoding technique is good or not, or whether out of these parameters and what parameters is good and what parameters is bad. Okay, so these parameters will be key to identify the characteristics of a different line codings. So bandwidth, you already know like what is the bandwidth. Okay, so range of frequencies basically that will be basically defining like for what range of frequencies. This is basically being perfectly defined. Baseline wandering. So baseline wandering is one of the term that is basically used to consider the power that is being utilized by the system. Suppose any encoded waveform is there. So after encoding, there will be a signal. So suppose this is the signal. It has been considered like if this is the signal, so whatever portion is high, the similar portion is low, high and low, high and low. So overall, if we talk about the average power, if we consider, so the power is going to be like not focused to either high or low side. It is equally decided. Power will be closer to the 0 level. Okay, or it is like equally distributed on the upper side, positive side and negative side. So then if this type of signals are there, it will not be having like baseline wandering. There will be no baseline wandering in this type of signal. If any signal is there, like if it is defined likewise, only it is going above the positive side only. So if it is only positive side, it will be having the baseline wandering. Okay, so this is the baseline wandering parameter. Complexity in the sense, while implementing this concept, so whatever how it is implemented, that will be the defining the complexity. One is called DC component. So DC component is like in the first waveform, the DC component is considered to be 0. So 0 in the sense whatever the positive amount is there, similar is the negative. So positive and negative, overall DC component is 0. But here the DC component means the average value, because here the average value is, suppose it is 1 or A is there and this is 0. Again A is there, then 0 is there. So average value will be like in between the 0 and A. So it will be like, suppose it is in half. So this half A by 2 is the DC value or the DC component of the waveform or the signal. So if DC component is there, if DC component is not 0, if DC component is not 0, it is not that efficient line encoding. So in efficient type of line encoding, the DC component should be 0. Next is self synchronization. So these waveforms are the line encoders, or the signal that we are going to convert digital signal, that is after conversion the digital signal is obtained. It should be such that it should be having self synchronization. If suppose there is some delay into the signals, it should be having some indicators to identify a synchronization into the bits. Okay, so that we will study later into the slides. Next is built-in error detection. So if it is having error detection, then it will be identified. So either the line encoders are having, line encoding technique is having built-in error detection or not, that will be defined. Immunity to noise, so there should not be any noise effect, so that will be affecting coding techniques. So these are the different parameters that will be basically defining. So here it is like, it is saying the effect of lack of synchronization. So it is saying like, what is the effect of lack of synchronization? If suppose there is no self synchronization is there, if any line encoding is there that is having no synchronization, if no synchronization is there, then what will be the effect? So this is the signal that is sent, and this is what that is received. If there is no synchronization, its meaning is like this synchronization, lack of synchronization means the transmitter is there and the receiver is there. Both are having different clock cycle or the clock period, or there is some delay in between. Like here, the clock frequency is here. Suppose clock frequency is like 2 megahertz, and here the clock frequency is suppose 10 megahertz. If the transmitter and receiver is having different clock frequencies, then this type of error can be there. So it's this is the send signal and this is the received. So at the receiver, basically it decodes the signal. So while decoding, it will be decoded like suppose it's signal or suppose it is 2 and it is suppose 4. So if frequency is high here, the receiver side. So receiver side frequency is high means time period will be less. So here time period is high at the sender side. So if time period is less, so each time it will be asking for like, if it is high, that means 1 is received. So after next time period, again it will be checking at this time period. Up to here again it is sender is high, so it will be high. Okay. Next is like it should be going to check at this time. So at this time it is low, at this is low, so it will be low. So again at the next time cycle it is checking, it is low again, so it is detecting low, means 0. Next is that is going to be high. So in this region it is high, so it is detecting 1. Again in this region it is high, it is again detecting next 1. So that means what it is doing is 1, 2, 3, 4, 5, 6, 7, 8 bits are being sent at the sender side, but at the receiver side 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bits are received. So because of the unsynchronization of the clock, or because of some smaller time period or larger time period, because of time period difference or frequency difference, there can be error in decoding the signal or the value or the data that will be decoded, that will be of different. It is 8-bit and here it has received the 12-bit, so it is wrong decoded. So that type of error can be there. So this is the effect of synchronization that is being shown. So while looking for different type of encoding techniques, we will be looking at different parameters. So these are the different parameters we will be thinking in that way. So either it is having higher bandwidth or lower bandwidth, baseline wandering is there or not, complex, if the system is complex or easy, is there any DC components or not, likewise, or synchronization technique, synchronization bits are available or synchronization mechanism is available into that line encoding or not. So that we need to think of.